In this example, we're expanding the implicit function theorem to find the partial derivatives of z with respect to x and y when z is an implicitly defined function of x and y. So here we have a three-dimensional surface and z is implicitly defined. So in order to find the partial derivative of z with respect to x, we need to first establish this cap f function. And again, that is found simply by getting all the terms to one side of the equation. So we have x cubed plus y cubed plus z cubed plus 6xyz minus 1, that's equal to 0. Now, this function that we get here on the left with all the terms is what we're going to let our cap f at xyz function be. So let's just formalize that right here. And now we're going to need to calculate the first partial of this function with respect to x and the first partial of this function with respect to z, because those are what's needed in the implicit function theorem. So with respect to x, we treat y and z as a constant, so the derivative of x cubed is going to be 3x squared. Y cubed is a constant, z cubed is a constant, y and z are constants over here, and we'll end up with the derivative of negative 6x, which will just be negative 6 times those constants, so minus 6yz. The first partial with respect to z treats x's and y's as constant, and so the derivative of z cubed is 3z squared. X and y are constants, and the derivative of z to the first is going to be just 1 times these constant multipliers, which is negative 6xy. So now we put these two together to get the partial of z with respect to x, which is the opposite of first partial of f with respect to x divided by first partial respect z. So in the top, we'll go ahead and put that negative up in the top there. And first partial respect x is 3x squared minus 6yz. And first partial respect z is 3z squared minus 6xy. And we can simplify this a little bit by pulling out a 3 out of the top and the bottom. So we have negative 3 times x squared minus 2yz over 3 times z squared minus 2xy. And once we cancel these 3's, we see that we have negative still on the outside, x squared 2yz over z squared minus 2xy, and this is our first partial of z with respect to x. Now we were also asked to calculate the first partial of z with respect to y, in which case we'll need the first partial of cap f respect y divided by first partial of f respect z, which we've already calculated, but we do need to find first partial of f respect y. So as a reminder, first partial of f respect z was 3z squared minus 6xy. We also need to now find the first partial of f respect y. That's going to be holding x and z constant. So x is constant, z is constant, and the derivative of y cubed is 3y squared. Minus x is constant, z is constant, 6 is constant, the derivative of y is 1, so this is minus 6xz. So the implicit function theorem says that the first partial of z respect y is going to be the negative first partial of f respect y divided by first partial f respect z. So again, let's put the negative up here in the numerator. And first partial f respect y was 3y squared minus 6xz. First partial respect z in the bottom is going to be 3z squared minus 6xy. And again, let's factor out those 3's, which leaves y squared minus 2xz inside up in the numerator. And in the denominator, we factor out the 3 to get z squared minus 2xy. And let's cancel the 3's. So this is now minus the quantity of y squared minus 2xz divided by z squared minus 2xy, which is our final answer for the second part.